project is on the application of algebraic concepts under the topic of systems of equations. So we want to deal with Gaussian method, that is the Gaussian elimination. From which this Gaussian elimination is also called row reduction. It's also called row reduction. It's actually an algorithm in linear algebra for solving a system of linear equations. It is usually understood as a sequence of operations performed on a corresponding matrix of coefficients. For example, want to solve a system of linear equations given by negative 3x plus 2y minus 6z is equals to 6. Second equation is 5x plus 7y minus 5z is equals to 6. The third equation is x plus 4y minus 2z is equals to 8. So I'm having a system of linear equations. There are three of them. So we want to use the Gaussian elimination method to solve for the variables of interest. Now, no equation is solved for a variable, so I would have to do the multiplication and addition thing to simplify this system. In order to keep track of my work, I write down each step as I go, but I will do my computation on scratch paper. Here is how I did it. The first thing to do is to get rid of the leading x terms in two of the rows. For now, I'll just look at which rows will be easy to clear out in my system. I can switch rows later to get the system into upper triangular form. There is no rule that says I have to use the x term from the first row, and in this case I think it will be simpler to use the x term from the third row, since its coefficient is simply 1. So I'll multiply the third row by 3 and add 8 to the first row. I do the computation on a scratch paper as follows. So I'm taking this negative 3x plus 2y minus 6z is equals to 6. I have 3x plus 4y minus 6z is equals to 24. Remember, I'm using the third row here. If we consider this to be my first row, my second row, and my third row. So I have 3x plus 4, 12. Sorry, this must be 12 because I have to multiply this 4 by 3, coefficient of 3 from the first row. This is minus 6z is equals to 24. And then I write down the results. Negative 3x plus 2y minus 6z is equals to 6. 5x plus 7y minus 5z is equals to 6. I have x plus 4y minus 2z is equals to 8. So this is the first, actually from the example. what I'm doing, I do the transformation here by taking 3 multiplied by root 3 plus 1. So what I'm having is 14y minus 12z is equals to 30. 5x plus 7y minus 5z will be 6. The third row is x plus 4y minus 2z is equals to 8. Is equals to 8. When we were solving two variable system, we could multiply a row, rewrite the system off to the side, and then add down. There is no space for this in a 3 variable system, which is why we need the scratch paper. Since I didn't actually do anything to the third row, I copied it down and changed into the new matrix of equation. I used the third row, but I don't actually change it. Don't confuse this using with changing. To get the smaller number of coefficient, I'll multiply the first row by 1/2. By 1/2. And this is what I will get. The first row, so I have 14y minus 12z equals to 30. From this, I have 5x plus 7y minus 5z is equals to 6. X plus 4y minus 2z is equals to 8. Then transformation, multiply by 1/2 of row 1. So what I'm getting is 7y minus 6z is equals to 15. 5x plus 7y minus 5z is equals to 6. X plus 4y minus 2z is equals to 8. Good. Now I'll multiply the third row by -5 and add this to the second row. I do my work still on the scratch paper, so I'll have 5x plus 7y minus 5z is equals to 6 minus 5x minus 20y plus 10z is equals to 40, which is negative. It's negative. So this will be negative. That's plus 7y minus 20y, get negative 13y plus 5z is equals to negative 34. Correct. And then I write down the results. Write down the results. 7y minus 6z is equals to 15. 5x plus 7y minus 5z is equals to 6. X plus 4y minus 2z is equals to 8. Good. So want to do some transformation. Minus 5, row 3, and then I have to add row 2. So I have to do the elimination. So I'll get 7y minus 6z is equals to 15. Note, in my second row, I'll have negative 13y plus 5z, which will be negative 34. Correct. I have x plus 4y minus 2z is equals to 8. Well, because we were actually dealing with negative 5 row 3, which is this, plus row 2, which is this. That is why we are getting elimination of x's, which is actually our main objective. So I don't do anything with the first row. Note that. So I copied it down and changed. I worked with the first row, but I only worked on the second row. So the second row is updated, and the third row is copied over and changed because of the rule here, -5 row 3 and plus row 2. Okay, now the X column is cleared out except for the leading term in the third row. As we can see here, only the third row containing the X term. So next I have to work on the Y column. But warning is that since the third equation has an X term, I cannot use it on either of the other two equations anymore, or I'll undo my progress. I can work on the equation but not with it. If I add twice the first row to the second row, this will give me a leading one in the second row. I won't have gotten rid of the leading Y term in the second row yet, but I will have converted it without getting involved in fractions. To inform that, it is simpler to deal with. Okay, you should keep an eye out for this sort of simplification. First, I do the scratch work as follows. Have -13y plus 5z, this is the second row, is equals to -34. 14y minus 12z is equals to 30. Doing my computations, that y minus 7z will be equal to -4. And then I write down the results. 7y minus 6z is equals to 15. 13y plus 5z is equals to -34. I'm copying this. X plus 4y minus 2z is equals to 8. This will undergo a transformation of 2r1 plus r2. So I will have 7y minus 6z is equals to 15. Y minus 7z is equals to -4. And x plus 4y minus 2z will be equal to 8, because actually it's not changing, it's just touching row 1 and row 2. So far so good. Now I can use this second row to clear out the Y term in the first row. I'll multiply the second row by -7 and add first row 1. I will add the first row. Yes, I do the scratch work, continue. So I'm having 7y minus 6z is equals to 15. Then 7y plus 49z is equals to 28. So this one will be 43z, this z is equals to 43. And then I write down the results. As follows. Yes, from this. So I have 7y minus 6z is equals to 15. Y minus 7 z is equals to -4. Then I have x plus 4y minus 2z is equals to 8. Good. Transformation under -7 r2 plus r1, and I'll get 43. Z is equals to 43. Y minus 7z is equals to -4. X plus 4y minus 2z is equals to 8. Good. I can tell what z is now, but just to be thorough, I'll divide the first row by 43. Then I rearrange the row to put them in upper triangular form. So I divide the first row by 43. Then I have to rearrange them, of course, to get to my z. So copying this, here. So I will have 43 z is equals to 43. I have y minus 7z is equals to negative 4. X plus 4y minus 2z is equals to 8. Good. So what I'm doing is that I'm taking 1 over 43 of R1, that's row 1, to get transformation of this. That is z is equals to 1. Good. Y minus 7z is equals to negative 4. And x plus 4y minus 2z is equals to 8. See that? Nice. So this follows that x plus 4y minus 2z is equals to 8. Then I have y minus 7z is equals to negative 4. And z is equals to 1. What I've done, I've just rewritten this part as an upper triangular form. Nice. Now I can start the process of back solving. The process of back solving, I have my y minus 7. My z is 1. We've seen from the previous system. So is equals to negative 4. So y minus 7 is equals to negative 4. And my y will be negative 4 plus 7 is equals to 3. Good. For the second row, having the equation now x plus 4 z, that is y. Since my y is now 3, so this one will be 3 minus 2, z is 1, is equals to 8. So x plus 12 minus 2 is equals to 8. And x, this is 10, that's plus 10 is equals to 8. So my x is equals to negative 2. Then, you can say then the solution is x, y, z, which is equals to negative 2, 3, and 1. Negative 2, 3, and 1. Note, this is nothing sacred about the steps I used in solving the above system. There was nothing special about how I solved this system. You could work in a different order or simply simplify different rows and still come up with the correct answer. Now, the application of Gaussian elimination, because it has got a real application in real life situation, that Gaussian elimination actually is robust fingerprint image enhancement. Gaussian filter is used to enhance the image. The SGE we are talking about method is also appropriate for solving linear equation on mesh connected processors. Then the Gaussian method is also used in scheduling algorithm. So that's the most important application of Gaussian elimination method. Thank you very much. I appreciate it.